You know that feeling, right? That little nagging feeling of distrust sometimes, maybe lurking under the surface of modern life. It kind of pops up whenever you hear about another big data breach, or maybe when you realize you have, well, zero idea where your clothes or your food actually came from. We're just dealing with government bureaucracy sometimes. That feeling of inefficiency, that sort of systemic opacity, that lack of verifiable truth. That's really what we want to dig into today. Our mission here is to move way beyond the crypto charts and really dive deep into the foundational tech, the blockchain, and specifically how it might offer a path towards, well, a fundamentally more secure, transparent, and maybe even equitable future. How it's transforming industries you actually use every single day.
Exactly. We're really zeroing in on the plumbing, so to speak.
Mm.
For you listening, forget the speculative assets just for a moment. Our sources are showing that the real revolution, it seems to be happening in the infrastructure, that core mechanism that creates and maintains trust in a verifiable, distributed way. We're looking at how this basic structure is really poised to change how we verify almost everything, from land deeds to, say, medical records.
Okay, let's unpack this then, because yeah, the immediate mental shortcut for most people is Bitcoin, just straight to crypto. So if we're serious about moving past all that volatile hype, we really need to bust that myth right now, focus on the underlying engineering.
Yeah, it's the essential first step, definitely. When we talk about blockchain, fundamentally we're talking about distributed ledger technology, or DLT. In its simplest form, you could think of it as a distributed, immutable ledger.
Immutable.
Immutable, that's the key word there. It just means once a record is entered, it cannot be changed or deleted, period.
And crucially, it's distributed. Like you said, it's not stored on, I don't know, one bank server or one government computer somewhere. Why is that distribution part so key to unlocking this broader societal potential?
Well, because that distribution eliminates the single point of failure. And it also removes the need for a centralized intermediary, the middleman, the one who usually enforces trust.
Right.
It's basically a mechanism for achieving consensus among lots of different parties who might not even know each other. Think of it like a digital public notary, but one that everyone in the network is monitoring all at the same time.
Oh,
So if everyone has a copy and every new edition has to be verified by the majority, well, how can one person cheat the system?
they can't.
They really can. And that underlying power, creating these verified, trusted records without having to rely on some powerful central entity, that's really where the societal transformation begins to spark.
That framework helps a lot. Okay, so if the core tech creates these verified, trusted records, let's jump straight into where this is actually solving problems today. Let's move from theory into, tangible, practical applications. Where is this working in major industries right now?
Yeah, good idea. We've seen some really massive quantifiable transformations already in supply chain transparency. Because legacy supply chain systems, they're often incredibly vulnerable to fraud, inefficiency, just lack of accountability, especially for things like, perishable goods or high-value items.
Okay, so give us a concrete example then, maybe from the sources. What does blockchain do here that, I don't know, a standard database can't? What's the real difference?
Right. Well, the key difference really comes down to trust, doesn't it? Standard databases, you have to trust the owner of that database, the central administrator.
Right, the single owner, yeah.
Yeah. Exactly. Whereas blockchain relies on consensus across the network. Our sources highlighted examples like IBM's Food Trust Initiative, for instance. Traditionally, if there was some kind of food safety issue, tracing the source of an item, let's say a mango, it could take up to 7 days of phone calls, emails, paper shuffling, just chaos.
7 days.
Yeah. But using the immutable digital record on the blockchain, they got that tracing time down to 2.2 seconds.
2 seconds. That's incredible.
It is. And that massive reduction in friction, in delay, potential loss, that is the real value proposition here. It guarantees that transparency from farm to fork, as they say.
That efficiency gain is just huge. But okay, when we talk about transparency, that raises an immediate friction point when we shift to something like highly sensitive data, like healthcare. I mean, healthcare data security is absolutely non-negotiable.
So wait, isn't putting sensitive medical data onto a transparent ledger incredibly risky? How do the sources handle that tension between transparency and privacy? That's an excellent point, and it definitely requires some nuance. The industry uses different types of blockchains, you see. For medical records, they're very rarely using the same public chains as, say, Bitcoin. Instead, they tend to use what are called permission or private blockchains.
Okay, permission, so controlled access.
Exactly. The chain itself maintains that immutable record, but it's usually a record of when data was accessed and by whom. So it creates this perfect audit trail. But the actual patient data, that's often encrypted and stored off-chain, somewhere else entirely, and the access keys are managed on the ledger.
Ah, okay. So the blockchain isn't holding my, sensitive MRI image itself.
Right.
It's holding the unchangeable record of who looked at the file containing my MRI image and exactly when they looked at it.
Precisely. And this secures patient records. It can speed up clinical trials because you have verified tamper-proof data,
Yeah.
and it radically enhances drug traceability, ensuring that medicines are authentic, that they're not counterfeits as they move through the whole distribution chain.
And that verification concept, it seems like it extends directly to the livelihood of creators, too. Let's pivot for a second to intellectual property,
Hmm.
IP protection. Because, I mean, in the digital age, artists, creators, they struggle constantly to prove when something was created or, who owns the original digital asset.
Yeah, that's a huge problem. And blockchain offers a pretty elegant solution through timestamping. So instead of waiting potentially months for a copyright office to process paperwork, a creator can immediately submit a unique identifier of their work, usually a cryptographic hash, right onto the blockchain
Instantly.
instantly. And this permanently timestamps the moment of creation. So if a dispute comes up later, they have this verifiable, absolutely incontrovertible proof of ownership tied to that specific moment in time. It protects them against digital theft, against plagiarism, often far more efficiently than, the old legacy systems.
Okay, this is where it starts getting really interesting, I think. Moving beyond just corporate efficiency and into, the architecture of society itself. Let's shift our focus now towards governance, public services, and maybe building trust in this digital age we're in.
Yeah, if we connect this to the bigger picture, just think about processes that are currently kind of crippled by distrust, like elections, voter identity verification, ballot integrity. These are perennial issues, right? The source material we looked at explains how blockchain could enable secure, tamper-proof systems for digital identity verification first, and then potentially for democratic processes like voting itself.
It sounds almost idealistic, though. What's the practical mechanism? I mean, why is it better than, say, current electronic voting machines or even just paper ballots?
Well, the current systems, they either rely on you trusting a centralized administrator, the machine operator, the election board, or they introduce physical vulnerabilities like with paper ballots.
Right. Tampering, losing them.
Yeah. Exactly. A blockchain-based system could potentially secure voter identities and ensure two critical things. First, that only eligible, verified individuals can cast a vote in the first place. And second, that once that vote is cast, it's instantly added to the immutable ledger and cannot be altered or removed by anyone. So you're essentially securing the tallying process against manipulation and providing this verifiable record that, in theory, could be accessible by all authorized election monitors. That fundamentally changes the conversation about trust in election outcomes.
Okay, that's a big one. And let's move to another governance headache that affects millions globally. Property ownership, land records. Disputes and outright fraud plague property markets, particularly in developing nations where records might be, fragmented, paper-based, easily corrupted.
Oh, absolutely. The complexity often comes from trying to reconcile different records. You might have the seller's record, the bank's record, the local registrar's record, all potentially saying slightly different things or containing fraudulent info.
It's a mess.
It can be. But if we start migrating these records onto secure land registries built on blockchain, you create one unified, transparent, and secure source of truth. Our sources indicate this doesn't just virtually eliminate title fraud, it also potentially slashes the time needed for property transactions, from, say, months down to maybe minutes, which simplifies a core pillar of wealth generation for ordinary people.
That efficiency point also seems to translate directly into how our cities are managed, particularly with these smart cities initiatives we hear about. If data is secure and instantly verifiable, maybe we can start automating certain public services.
Exactly right. We are seeing examples, early stage perhaps, but examples where blockchain provides that decentralized trust layer needed to manage public resources more efficiently. Think about regulating energy grids, especially with more people having decentralized solar power generation on their roofs, or optimizing traffic systems based on real-time verified data. It could automate agreements and resource allocation, ensuring public infrastructure operates based on rules coded right into the network itself. Makes the whole process more objective and transparent.
And crucially, this technology could be a really powerful tool for empowering those who've traditionally been excluded. We really should dedicate some time to social inclusion here. maybe starting with the unbanked.
Yeah, that's incredibly important. Globally, something like 1.7 billion adults are estimated to be unbanked. They can't easily access credit, save reliably, or fully participate in the modern economy. Often it's because they lack, say, a verifiable identity recognized by traditional banks, or they simply don't trust those institutions.
Or the institutions aren't accessible.
Right. So, blockchain-based digital identity combined with secure digital wallets could provide access to secure transactions, maybe even digital assets, without needing that traditional banking middleman. It has the potential to really level the financial playing field almost instantly for a huge number of people.
That is profound when you think about it.
Mm.
And relatedly, let's look at altruism, charity.
Mm.
Donor confidence often gets shaken by stories of, mismanagement or corruption in aid distribution.
Yeah, and blockchain can bring much needed transparency to altruism too. There are systems being deployed now that track charitable donations right from the moment the donor sends the funds, all the way until they're converted into actual goods or services on the ground.
So you can see the whole journey.
You can see the whole journey. It helps ensure donations actually reach their intended recipients, it helps prevent corruption in aid distribution, and it provides this auditable, verifiable chain of custody for every single dollar or fraction of a dollar donated.
This raises a really important question then about how we govern ourselves collectively, maybe even beyond national elections. The most radical shift might actually be in organizational structure itself, with the rise of these things called DAOs, decentralized autonomous organizations.
Ah, yes, DAOs. They represent an entirely new model for, well, for governance, potentially. They're essentially organizations run primarily by code, specifically by smart contracts deployed on a blockchain rather than by a traditional CEO or a board of directors. The rules for things like spending funds, voting on proposals, making decisions, they're all transparent and automated, enforced by the code itself.
Okay, so if I'm a member of a DAO, my voting power, or maybe my ability to propose changes, it's executed automatically based on rules coded into the system. It bypasses human interpretation or potential bias, right?
That's the idea.
But if the code is law, what are the challenges there? What are the inherent difficulties? Sounds a bit rigid.
Well, that's one of the main challenges. Code, once deployed on an immutable blockchain, can be incredibly inflexible, and coding errors or bugs can be catastrophic if they control large swaths of money or critical decisions. And furthermore, while the technical governance is novel, DAOs still face pretty significant hurdles. There's legal ambiguity. I mean,
Yeah.
how does a DAO even operate within existing legal frameworks? Is it a company, a partnership? Nobody's quite sure yet.
Right.
And there are engagement issues too. How do you ensure high quality debate and prevent voter apathy among potentially thousands of token holders scattered globally? So it's a powerful idea, definitely, for community governance, maybe even corporate governance down the line, but it's still very, very much in its infancy, still experimental.
That's a critical perspective to have. And for you listening, it's crucial to understand that while this potential seems vast, these hurdles for widespread adoption are real. We need to face them head on. Let's talk specifically about scalability and interoperability. Those seem like big technical roadblocks.
Absolutely. Scalability is perhaps the biggest technical challenge right now. Can a decentralized network actually handle the sheer transaction volume of potentially billions of users globally? I mean, think about the speed of Visa or MasterCard, the transactions per second they handle. Many current blockchain implementations are still struggling quite a bit to achieve that level of throughput without sacrificing the core principle of decentralization.
Right, the trade-offs.
It's a trade-off. It's sometimes described as trying to move global commerce on, like an old dial-up modem. We need fiber optic speed, essentially, for this to become mainstream infrastructure.
And then there's that messy integration challenge, interoperability. These new, shiny blockchain systems need to somehow talk to decades of existing legacy systems. The old banking mainframes, the existing healthcare databases, the government registry systems that have been around forever.
Yeah, it's basically a massive translation problem. How do we build reliable bridges between these highly secure, distributed, novel systems and the often centralized, sometimes vulnerable systems they're meant to eventually replace or augment? It requires developing standardized protocols, common languages, and probably huge investment to integrate them seamlessly without accidentally creating new vulnerabilities right at those connection points. It's complex work.
And of course, underpinning all of this, the tech often seems to be running way ahead of the lawyers and the policymakers. That ongoing challenge, the evolution of the regulatory landscape, that seems like a constant source of friction and uncertainty.
Oh, the tension there is palpable. You have Regulators trying desperately to get their heads around the implications of decentralized finance, DeFi, digital identity, self-executing contracts, things that just don't fit neatly into, 20th century legal boxes and
It
definitions.
breaks the old models.
It really does.
Yeah.
And that uncertainty, it can definitely slow down adoption as big companies or governments hesitate to invest heavily without clear rules. But the sources are pretty clear on this. For this technology to move from being a niche innovation to becoming truly global infrastructure, regulatory certainty is essential. We need rules that manage to encourage growth while still protecting consumers. Eventually, the law has to catch up.
So, okay, wrapping this towards the listener,
Yeah.
what does this all mean for you? We seem to be far past the stage where blockchain was just some academic curiosity or only an investment vehicle, right? It feels like it's becoming a foundational technology being woven into the fabric of commerce and governance.
I think that's right. We're at a really critical juncture now. And the question becomes, what is your role in this revolution? Whether you're a consumer who stands to benefit from, say, instant product traceability, or maybe you're a patient who demands better security for your health data. Or perhaps you're an innovator yourself, thinking about how these principles of decentralized trust could apply to your own industry or community. You kind of have to engage with this technology now, at least intellectually. The shift is happening, and it's fundamentally reshaping who we trust and how we verify information and transact value.
Okay, so to try and synthesize all this,
Yeah.
the core takeaway seems pretty clear. Blockchain isn't just some volatile financial tool anymore. It represents a fundamental shift in how trust itself is brokered in the digital world. It directly addresses those issues of distrust and opacity we started this whole deep dive talking about. It offers these verifiable records across almost every sector we touched on, from supply chains to voting, land registries, even charity.
Yeah. And if we leave you with one final, maybe provocative thought to mull over, consider that core concept of immutability combined with truly decentralized trust. What if every critical piece of information imagine, from your fundamental digital identity to the deed for your house, or that charitable donation you made, what if it could be permanently recorded, verified by a network, and accessible to everyone authorized to see it? If that world comes to pass, what assumption that we currently hold about existing centralized power structures, the organizations we currently rely on to be the sole source of truth, what assumption would be the first one to fall? Think about the societal implications of potentially trusting code and consensus more than we sometimes trust a single human authority or institution. That's the really big question.